Hello everyone, welcome back to our third and final screencast for Chapter 4 Populations. We're going to pick up where we left off yesterday with growth rate fluctuations. To briefly review, the normal growth and decay of population size are called fluctuations. Fluctuations are caused by variables in the environment such as climate, food supply, disease, and activities of natural enemies. Climate is an example of a density-independent factor, which are abiotic factors. The temperature, weather, earthquakes, tornadoes, and hurricanes are not going to be affected by the size of a population, whether it's big or small. Conversely, food supply, disease, and natural enemies are all examples of density-dependent factors and are all biotic factors. The larger the population, the more vectors for disease. A vector is other animals that spread disease from one to another. There are other types of vectors, but for this portion of the class, we'll just consider other animals as vectors for now. The larger the population, the more the food supply will be divided up to each individual. Individuals of the same species are competing for the same food. More individuals, less food per individual. Additional factors of competition come from other species populations. This is considering the community of an ecosystem. We've talked about communities before in Chapter 3. If a population had unlimited food and space, it would grow at a certain rate, but factors in the environment affect the growth rate. Remember our S-curve for logistic growth, which the rate of population growth accelerates until growth reaches the point of maximum growth, and then the growth slows down as our population reaches the carrying capacity of our environment. Otherwise, our J-curve for exponential growth is unrestricted and the population grows infinitely without an upper limit, and it will grow and grow forever, seemingly. Populations may be measured in density. Density is the number of individuals in a given area. In the United States, we commonly measure our population density by states. States are artificial, human-created boundaries. These boundaries do not exist in reality. There is no actual line that divides California from Arizona, Mexico, Oregon, or Nevada. You can see in the map below are 50 states, and each is a different shade of purple. The darker the color the purple is, the more dense the population is in that state. We can see where purple is the darkest that the population of New Jersey where I am from, New Jersey is where I grew up, is the most densely populated state. Other states with very dense populations are California, where we live, New York, Pennsylvania, Massachusetts, Illinois. All these states have large populations within their states. All these states have large populations within their state borders. States that have a lighter shade of purple are less densely populated. For example, Montana, Idaho, New Mexico, North and South Dakota, and Wyoming. All have few people within their state borders. States with a medium shade of purple, Texas down here, Oklahoma, Arkansas, Missouri, Iowa, Wisconsin, Minnesota. Medium shade of purple have a medium density. They have an average population within their state borders. All that said, population density increases or decreases as time changes. An open population, a population that increases or decreases in size as individuals enter or leave the population, will usually reach a peak, then decrease, and then stabilize, level off. All populations have the tendency to spread from one place into other places. This spreading of organisms is called dispersal. We have 3 patterns of dispersal that we need to know. Uniform, here are our dispersal patterns. Uniform, our red square below, equal distribution throughout an environment. Examples being orchid trees and territorial animals tend to have uniform dispersal. Clumped, our purple square below. So we did uniform. Let's do that in a red color. Uniform. Then we have clumped. Our purple square below are organisms grouped together in an ecosystem. Examples are a pack of wolves, human families, flocks of birds, all examples of clumped dispersal patterns. And finally, our last dispersal type is random, our green square below. Organisms distributed by chance. Examples are free-floating marine plankton. Plankton do not have strong motility being the ability to move, so they use the ocean currents and waves to carry them around the ocean. Here again, on our next slide, we have more images of uniform dispersal, the penguins in Antarctica. And then we have clumped dispersal. We have a school of fish in the ocean. And then we have random dispersal, some ferns in a forest. So there are environmental factors that influence how organisms disperse themselves. Barriers may prevent organisms from spreading from place to place. There are 2 types of barriers. Physical barriers, such as mountains or bodies of water, rivers, lakes, oceans, can all stop organisms from spreading. There are also ecological barriers, such as the availability of food that may stop the dispersal. So if there's no food available for an organism to consume, they're not going to disperse into that area of the ecosystem. How do barriers affect our population, the human population? There are a few barriers to prevent human dispersal, because through our creativity and our ingenuity, our intelligence, we have developed methods to conquer our barriers. Airplanes were first successfully invented by the Wright brothers, who are from Dayton, Ohio. Others had attempted to successfully take flight, but the Wright brothers were the first at Kitty Hawk, North Carolina in 1903. Airplanes have enabled humans to travel through air and travel over oceans and mountains in hours rather than how our ancestors traveled by foot, horse, or wagon, which took days, months, or even years to travel across the continent of North America. Continuing humans' ability to break through barriers in less than 60 years after the 1903 Kitty Hawk flight of the Wright brothers, Yuri Gagarin of Russia, the former Soviet Union, became the first human to orbit the Earth in 1961. Yuri Gagarin was the first human to fly in outer space. Fast forward to today, just recently, last month, 2015, Amazon.com founder Jeff Bezos has his own spaceflight company. He's not NASA. He's not part of a country's own spaceflight program. He has the wealth to own his own spaceflight company named Blue Origin. His company successfully landed in an unmanned test rocket back on Earth. One of the biggest barriers of space exploration is that it's expensive to build rockets that are used once to launch spacecraft into orbit. Bezos' company has developed the first reusable rocket. This will drastically reduce the cost of spaceflight. So over that course of time, from 1903 to 2015, humans went from the inability to fly. We were purely terrestrial. We were on land. We could walk. We could drive. We could ride horses, but we had no means to fly. And now airplanes are ubiquitous throughout many nations. to orbiting the Earth, landing a man on our moon. And now we're able to launch and land rockets back on Earth. You've made that much progress in 112 years, just over a century. What barriers are humans capable of overcoming in the next 100 years? Landing on Mars, colonizing Mars or another planet, interstellar space travel. You are the young minds that are going to discover the technologies to overcome these barriers. Earth's carrying capacity is limited. There's only so much food, energy, water, and space for humans to populate. And the effects of global climate change will change the limiting factors of Earth on the human population. Once the human population reaches the Earth's carrying capacity, which we will, the human population is doubling every 50 years and our available resources remain the same. There are an estimated 7.2 billion people currently on the planet Earth in 2015. In another 50 years, the human population will be an estimated 14.4 billion people. Overpopulation may cause the extinction of the human race due to the limiting factors of food, water, and space. So that concludes our Chapter 4 notes, and those are all things we need to consider as we're studying our articles, noticing how other limiting factors are affecting the populations in our articles. And these are all good examples of how species interact with each other, how we affect one another by our actions or our inactions, and just some ideas and thoughts about problems the human race will encounter over the next 50 to 100 years in your lifetime that need solutions. And these are all questions that you guys have the power to answer. You have the intelligence, the ingenuity, and the creativity to answer these questions and solve our problems for the planet Earth. All right, guys, I will see you all tomorrow, and have a good evening. Thank you. Bye.